Welcome to Study Loop.
Okay, so we have an element whose n equals 1 and n equals 2 shells are full. And that element has 6 electrons in its n equals 3 shell. So we need to identify the element, determine its group number, whether it is metal or nonmetal, and identify the orbital in which the last electron is found. Okay, well, what are the orbitals that correspond to n equals 1 and n equals 2? Right? So to me, what this looks like, if the n equals 1 and n equals 2 element shells are full, that the 1s shell has 2 electrons in it, right? And that also the 2s and the 3p are also full, having 2 and an additional 6 electrons in it, right? That's what it means. So this would be n equals 1 being filled, and this, oops, I wrote 3p instead of 2p. And this is what n equals 2 being full means, okay? And then in the n equals 3 shell, we have 6 additional electrons, okay? So where are those? Well, first, we're going to fill 2 of them into the 3s, okay? And then we've got the 3p. 3p, and there'll be 4 in the 3p. Okay, so that's where our n equals 3. These are full, and this is 6 electrons. Okay, so at this point, we can get some idea of what element this is, right? Because if we're assuming that this element is neutral, right, and that it has the same number of protons as electrons, then we can identify what its atomic symbol is. Okay, so we've got 10 electrons in the n equals 1 and n equals 2, and then an additional 6 electrons in the n equals 3 shell, which tells me that this is element number 16, right? So let's look at a periodic table. Element number 16 is sulfur. So this is sulfur. Okay, so that's the element. What is sulfur's group number? Again, we'll look at the periodic table. It's group number 16, also known as 6A. All right, is it metal or non-metal? Right, this is kind of the dividing line between metals and non-metals. It's above it, so it's a non-metal. You can also look at this color coding here and identify the orbital in which the last electron is found. Well, we kind of started with that, right? Because I was filling in S, 1s, 2s, 2p, 3s, 3p, and 3p was the last orbital filled. Therefore, the last orbital filled was the 3p